back. We're in section 5.1. We're going to do example 4, and we're going to write equations of bisectors actually in the coordinate plane. So yeah, you guys, you're going to get to use your algebra. I know you're excited about that. Okay, we're going to write an equation in point-slope form. If you don't remember what point-slope form, that's y minus y1 equals m times x minus x1. That's point-slope form. Remember, the whole point of that is you need to know two things to use this formula: a point and the slope. That's how you use this formula. You got to know a point and the slope. All right, so write an equation in point-slope form for the perpendicular bisector of the segment with endpoints A, which is -1, 6, and B, 3, 4. They have drawn A for you here as well as B. And we need to do a perpendicular bisector. We need the equation for basically in the video here. It's not color coded on your paper, but we're looking for the equation of this blue line. We need that line in point slope form is what we're after. Okay, not the original segment, but the point slope form. All right, now to find a point, we need, and they want the perpendicular bisector. So, well, a bisector would be the midpoint. Okay, so they've already graphed AB for us. They did that for us, so you don't have to take the time to do that. You may need to do that in future problems, but they've already graphed it for us regarding at least video notes. All right, so the very first thing after you graph that you're going to do is you're going to find the midpoint of AB. Okay, so you're going to add your x's. That would be -1 plus 3. Divide that by 2. Then add your y's, 6 and 4, and divide that by 2. Okay? So that's going to give us the midpoint. -1 plus 3 is 2. 2 divided by 2 is 1. And 6 plus 4 is 10. 10 divided by 2 is 5. So here's your midpoint, 1, 5. All right, that's good because we need that point. That point is on our perpendicular bisector. Okay, that is the point, a point on our perpendicular bisector for which we need to write the equation in point-slope form. Now, we've got to find the slope of the perpendicular bisector, but first you need to find the slope of the original segment we're basing this on. So we need to find the slope of AB. Okay? You can use the slope formula, but since it's graphed, you know how much I like using rise over run. I recommend you doing rise over run. You can use slope formula. They have it right here. Of course you can use that. So if we start here at B, go up 2, so that's plus 2, and then left 1, 2, 3, 4, left 4. So that means the original segment, AB, has a slope of -1/2. Now, what would be the perpendicular segment? The slope of the perpendicular segment, or the perpendicular line, what would that be? Now remember, to figure this out, you can do all this mentally. There's no real trick to it other than you just got to remember that opposite reciprocals, that's the key to finding perpendicular slopes. So what would be the opposite? That means the opposite sign. Reciprocal means flip your number over, flip the fraction over. What would be the opposite reciprocal of -1/2? If you're going, oh, it's 2, you're right, okay? And that's the slope we're going to use in our point slope form, okay? So now we have a point, which was our midpoint. We have our slope, which is our perpendicular slope, and now we can plug into y minus 5 is equal to 2 times x minus 1. And that's the equation of that blue line in your graph there. Okay, so I'm going to leave this, check it out right here. That's going to be extra credit for you. Try it on your own. Graph that on some graph paper and sketch it out, and then see if you can calculate first of all, the midpoint of that segment PQ, find the slope of PQ, and then use that slope to find your perpendicular slope for your new line. Okay? And then put it in point slope form. Good luck with that. Bring your questions to class.